Somewhere in your body right now, there is a version of you from 8 years ago. Not metaphorically. Almost every cell you're made of has already died and been replaced at least once since then. You are, biologically speaking, already a copy of yourself. Which means the question, what if you could teleport, isn't really about physics. It's about something you've been quietly ignoring your entire life, something teleportation just happens to force you to look at directly. Here's the reframe. You picture teleportation the way science fiction trained you to. Step into a booth, get scrambled into light, reassemble somewhere else and walk out exactly as you were, just faster than a plane ride. That version of teleportation is fiction because it skips the one detail that actually matters. To move you anywhere, a teleporter has to first know precisely where every atom in your body is. And the moment you ask what precisely means, physics stops letting you look away. In 1927, physicist Werner Heisenberg formalized what's now called the uncertainty principle. It states that you cannot simultaneously know both the exact position and the exact momentum of a particle. The more precisely you pin down where something is, the less you can know about how it's moving, and vice versa. This isn't a limitation of our instruments. It's a fundamental feature of reality at the quantum scale. So a teleporter that needs to scan the exact position of every particle in your body runs headfirst into a wall the universe itself put there. You can't copy what you can't fully measure. But physicists in the 1990s found a strange workaround, and it's stranger than the problem it solves. In 1993, a team led by physicist Charles Bennett proposed a method now called quantum teleportation. It doesn't scan and copy a particle's exact state. Instead, it uses a phenomenon called quantum entanglement, where two particles become linked so that measuring one instantly affects the other, regardless of the distance between them. Using entanglement, scientists can transfer the exact quantum state of one particle onto another, without ever needing to know or measure what that state actually was. In 2017, Chinese researchers successfully teleported a photon's quantum state from the ground to a satellite over 300 miles away, the current record for quantum teleportation distance. That's real. That happened. But here's the part that should stop you cold. What got teleported wasn't a thing. It was information. And that distinction is the entire point of this video. So picture the version of teleportation this technology could theoretically make possible, one that actually respects the laws of physics. A scanner reads the complete quantum information describing every particle in your body, transmits that information somewhere else, and a receiver reconstructs a body from new atoms using that exact information as a blueprint. The result would be, in every measurable way, same memories, same fingerprints, same laugh. Indistinguishable in every test you could run. And here's where the video stops being about physics and starts being about you. For that scan to work, the original version of you would need to be destroyed in the process. Not optionally, necessarily. The scanning process required to read quantum information at that level would disrupt the particles being measured, so there's no version of this teleporter where the original walks away intact while a copy also exists somewhere else. It's either the original stops existing here, or you end up with two people who both remember being you, arguing over a bank account. This is where philosophers have been circling for decades, long before quantum mechanics gave them new language for it. In the 1980s, philosopher Derek Parfit used exactly this teleportation scenario to challenge one of the oldest assumptions in philosophy of mind, the idea that personal identity depends on some continuous, unbroken thread connecting you through time. Parfit argued that what actually matters isn't metaphysical continuity, some soul-like thread persisting through your body. What matters is psychological continuity, the fact that the person on the other end has your memories, your personality, your intentions. If that's preserved, Parfit argued, you shouldn't fear teleportation any more than you fear falling asleep and waking up tomorrow. And that comparison is the twist that should genuinely unsettle you, because when you fall asleep tonight, something remarkably similar already happens. Neuroscientists have long noted that consciousness doesn't persist smoothly through deep, dreamless sleep. Your sense of continuous experience effectively pauses. The person who wakes up tomorrow morning has your memories, your personality, your unfinished conversations, but there's no evidence of some unbroken thread of awareness connecting tonight's you to tomorrow's you the way you assume there is. You already trust, every single night, that the person who wakes up will be close enough to you to count as you. Teleportation isn't introducing a new philosophical problem into your life. It's just making an old one impossible to ignore. Here's where it gets even stranger, and this is the part almost nobody thinks through. If teleportation via destruction and reconstruction is philosophically similar to sleep, then what about the cells you've already lost? The human body replaces most of its cells on a rolling basis. Your skin cells regenerate roughly every 2 to 4 weeks. Your red blood cells last about 4 months before being replaced. Even certain neurons, once thought to be permanent, have been shown by researchers to be replaced over time in some regions of the brain. The specific atoms that made up your body a decade ago are, for the most part, gone, recycled into soil, air, other organisms. You've already been reconstructed, just slowly enough that it never felt like an event. So here's the reframe landing fully. Teleportation doesn't invent a new kind of death and rebirth. It just compresses one you've already been living through your entire life into a single dramatic moment. Every time you've woken from anesthesia, every time you've woken from sleep, every time your body has quietly swapped out cells while you weren't paying attention, you've been running a slower version of the same experiment. The only difference teleportation adds is speed, and speed is exactly what makes something impossible to ignore. Now bring that back to your everyday life, because this isn't really about atoms and photons. It's about the parts of yourself you assume are permanent. The version of you that exists right now, reading this sentence, is not the same version that existed when you started this video 11 minutes ago. Some of your thinking has already shifted. A few thousand more neural connections have strengthened or weakened. You are, in a small but real sense, a slightly different configuration of the same continuous project. You've never been a single unchanging thing being transported through time. You've been a river that keeps looking like a river, made of different water every single day. So what if you could teleport? You'd survive the trip in every way that has ever mattered to you. Your memories intact, your relationships intact, your sense of self intact. What wouldn't survive is the illusion that there was ever a single, solid, unchanging you traveling through your life in the first place. There wasn't. There's just been a pattern continuously rebuilt moment to moment, cell to cell, memory to memory, close enough to yesterday's version to call itself the same name. And the next time you fall asleep tonight, you'll do what you've always done. You'll teleport quietly into tomorrow.